Hey guys, welcome back. I'm super excited to start a brand new chapter on Apache Flume. In the last chapter, we saw how to bring data from existing traditional RDBMS data stores into Hadoop. Apache Flume is a tool which is very similar to Scoop. When Hadoop first started out as an open source project, one of the very first use cases for Hadoop is to ingest application log files and do some analysis with it. If you shopped on Amazon.com, you know how powerful Amazon's recommendation engine is. From my personal experience, Amazon's recommendations are usually spot on. How do they do that? Well, Amazon's application servers could track and log my every movement on the website. What I click, in which order I click, where I spend my most time in the cart or reading reviews, etc. And with that data, they have algorithms to suggest products and make recommendations based on my behavior on Amazon.com. This is called clickstream or click data analysis. Now you have all the log files with valuable information about user behavior. Now the question is, how do you move them into your Hadoop cluster? We can simply copy the log files using copy from local HDFS command, correct? Yes, we can do that, but what would you do if you would like to stream the data from the log files in near real time as they are generated by the application servers? That is where Apache Flume can help. Flume is a distributed service for efficiently collecting, aggregating, and moving large amounts of log data into Hadoop. Flume is super simple to use. But before we go ahead and try out Flume, let's understand different components that make up Flume. To make Flume work, you need to configure a Flume agent. There are three main components required to configure a Flume agent: source, channel, and a sink. Let's talk about the source first. As the name suggests, it defines the source of data you're trying to ingest. Your source could be as simple as a log file, but Flume is not limited to ingesting just log files. Source could be a HTTP source, where Flume can listen to HTTP GET and POST, etc. It could also be a JMS source, where Flume listens to a JMS destination such as a queue. Or you can also write a custom source. For example, in our last lesson in this chapter, we'll see how to ingest tweets from Twitter using Flume into HDFS. An important function of source is to turn those incoming messages into Flume events. These Flume events will be then sent to the destination through the channel. And finally, the Flume events will be consumed by the sink. Let's talk about the sink first, and then let's talk about the channel. Sink defines the destination. That is, where you would like those Flume events to go finally. Your sink could be HDFS or a file in the local file system, or you can even configure your sink to write the Flume events to a NoSQL database like HBase, for instance. Just like you write a custom source, you can also write a custom sink. Now, let's talk about channels. Think of channels as pipes where Flume events flow through. Flume guarantees that data will not be lost between source and sink, and that guarantee is made possible using channels. Channels are buffers that sit in between sources and sinks. Sources write data into one or more channels, which are read by one or more sinks. We will see an example of multiple channel configuration in the next lesson. It is important to note that a sink can only read from one channel. Channels provide transactional capability that allow Flume to provide explicit guarantees about the data returned in a channel. That is, every event that is pushed to the channel will be delivered to the sink. A channel can be configured as one of four types: file, memory, JDBC, or custom. For example, if you choose to configure a channel as memory type, events will be held in memory between source and sink. If you choose the channel type to be JDBC, the events will be recorded in the database. So to summarize, source represents where the events or messages originate. It could be a log file, it could be JMS queues, etc. Sink represents the destination, and it could be HDFS, HBase, etc. And channel is more like a pipe where events flow connecting source and the sink. Okay, enough talking. Let's configure a Flume agent and see how it works in action. This is what we're going to do. We are going to consume messages returned to a log file by an application into HDFS. So, first we need an application which creates log messages. We can use one of the log files generated by Hadoop itself in our cluster, but sometimes Hadoop logs may not have messages coming in so frequently as we would like. So for that reason, I've created a small shell script, which basically appends a line of text with an incremental value into a file every 5 seconds. And will create a Flume agent to ingest all these messages into HDFS. Configuring a Flume agent is extremely simple. All we have to do is define the source, sink, and channel in a file. And that is it. Take a look at this file. First, we have to give names to the Flume components. That is the source, sink, and the channel. All properties you see on the left, like agent.channels, agent.sources, and agent.sinks, are Flume properties that we have to define. Agent.sources defines the sources which are involved in this Flume agent. We have only one source in our use case, which is the log file, and we are naming it tail-source. Agent.sinks defines the sinks which are involved in this Flume agent. Again, we only have one sink in our use case, which is HDFS, and we are naming it HDFS-sink. Agent.channels tells us the channel which are involved in this Flume agent. We have only one channel in our use case connecting the source and the sink, and we are naming it memory-channel. Now that we have named the source, sink, and the channel, let's define the source first. Take a look at these properties very closely. These three properties starts with agent.sources and followed by the name of the source, which is tail-source. You will see similar pattern in all the properties. Let's look at the first property. Our source for the log messages is the file returned by the application. So all the source has to do is to do a simple Linux tail command on the file. Agent.sources.tailSource.type defines the type of the source, and it is exec, short for executable. To know the list of all available types and the corresponding values to use for the source type property, refer to the Flume documentation, which we will refer in a bit. Next, agent sources tail source.command specifies the command to execute. Here we simply say tail-f and the location of the log file that our small little shell script writes to. Finally, agent sources tail source channels specify which channel this source should send the log message, or in technical terms, Flume events to. Here we give the name of the channel, which is memory-channel. Let's now configure the sink. Again, you can see here the property starts with agent.sinks, followed by the name of the sink, which is HDFS-sink, and type will define the type of the sink. Since our destination is HDFS, we have to define the type as HDFS. To know the list of all available types and the corresponding values to use for sink type property, or for any other property for that matter, refer to the Flume documentation. I've included this link in the lesson notes. In the documentation, you will also see all supported properties for all source and sink types. Let's look at the documentation for sink type HDFS. As you can see, there are several available properties for HDFS sink. You don't have to use all of them. We will only use the bare minimum ones which we need for this use case. And we will see additional properties as we go further. Let's now go back to the configuration file. First property is the type, and it should be HDFS, since the log messages should end up in HDFS. Next, use the HDFS path property to give the location in HDFS. So in our use case, Flume will create files under Flume simple directory with all the Flume events coming from the source. For the file type, we don't want our output file to be compressed, so we give data string. If you like the file to be compressed, we should say compress string. Finally, we need to specify the channel using the agent sinks HDFS sink channel property. And the sink will be using the memory channel, same as the source. Do you see any difference between the property to specify the channel for the sink and the property to specify the channel for the source? Any guesses? Look at the channel property for the source. It says channels, plural. And look at the channel property for the sink. It says channel, singular. Why? Guess, it's a good interview question. Because source can send its events to multiple channels. We'll see that configuration in the next lesson. Whereas a sink can connect to only one channel. And that is why you see a slight difference in the naming convention. Finally, let's configure the channel. We want all the events to be held in memory between the source and the sink. So we're going to configure the channel type as memory. That is it. Let's now see how to execute the Flume agent. Here is the command. Start with flume-ng followed by agent, and then for the conf property, specify the folder where you have the Flume configuration files. In our cluster, we have our configuration files under HARW workshop Flume simple directory. So that is what we'll specify here. Then -f property takes in the Flume configuration file. Give the name of the configuration file, which is simple-flume.conf. Next, you specify the level of logging you would like to have. We want more granular logging, so we are specifying debug here. And we want the log messages on the console, so we say console. Finally, the name of the Flume agent. If you look at the configuration file, you will see that we are starting all the properties with agent. So our Flume agent will be simply called agent. That is it. Very simple, right? Now let's go ahead and execute our Flume agent. But before we do so, we have to start our sample application, which is this script, so that it can write messages into log files. Let's go ahead and execute the script. Now this script is creating a file and writing some text into that file, which our Flume agent will read and push it to the channel, and finally these messages will end up in HDFS. So I'm going to let this script run. Let's go to the next screen where I'm going to execute this Flume command. So let's copy this command, execute it. As you can see here, Flume first creating the channels, which is the memory channel, and the memory channel is now created. Next, Flume will create an instance for HDFS sync, and then it starts HDFS sync. And finally, it will start the tail source. Our tail source is simply executing a tail-f command on logfile.log. So you can also see our sync is started, our source is started, and messages are started flowing through. And finally, you can see Flume creating files into the configured location in HDFS, that is Flume simple. Now let's switch to another screen and look up the location Flume simple. Flume simple. And there you go. And here are the files that are being created by the Flume agent as we speak. Why don't we open up one file and see how it looks? HDFS fscat. Let's pick a file, open it. And there you go. And these are the messages that are returned to the log file. Our source listens to the log file and reads these messages, converts them into Flume events, and the Flume events are then transferred through the channel to the sink and end up in HDFS. And as you can see, there are several files created under this directory. And there are properties that you can use to configure how you want to define the rollover of the files, which we'll see in the upcoming lessons. So to summarize, in this lesson, we saw a good introduction to Flume. We saw Flume is made up of three main components: the source, the channel, and the sink. We also created a simple Flume agent where Flume simply listens to a log file and local file system and transferred all those log messages to files in HDFS. In the next lesson, we are going to see a slightly different configuration where we have one source pushing messages into two channels consumed by two separate sink. And the configuration is simply called replication. See you in the next lesson.